Hello everyone, today we are going to learn how to solve exponential and logarithmic equations. I'm going to start with exponential equation. What is exponential equation? Well, something like exponential function involved in it. Exponential. So a typical exponential equation, 2 to the power of x equals 4. Here, unknown sits an exponent. So what is supposed to be x to raise 2 to that power and get 4? Well, it's kind of obvious for us that x equals 2, right? 2 to the power of 2 equals 4. But if something more complicated happens, how do we solve it typically? Typical solution of this equation is to use of a property of the power that it's one-to-one function. So if you have a to the power of u equals a to the power of v, because it's one-to-one function, means that for every x there is only one y. If y's are equal, then x's are going to be equal to x's in this case are u and v. And that's like if two powers are equal, then exponents are going to be equal. Well, let's see how it's going to work in the case of 2 to the power of x. So 2 to the power of x equals 4, but actually 4 is 2 to the power of 2, right? And we have base 2 raised to the power of x and base 2 raised to the power of 2. It's supposed to give you same results. So x equals 2. Very good. Well, let's try to solve something like similar maybe. My first example is going to be example 1. Let's try to solve 3 to the power of x plus 1 equals 81. Well, here we know that 81 is kind of 9 squared, right? Or 81 is actually 3 to the power of 4. Let me explain it. 9 by 9 equals 81, but each 9 is 3 square, and this 9 is 3 square, and if we combine all these 3's, we are going to get 3 to the power of 4. So using the rule and making exponents equal, we are going to find that x plus 1 equals 4, or x equals 4 minus 1, which is equal to 3. That's going to be our final answer. Okay, something a little bit more complicated. Example 2. 4 to the power of 2x minus 1 equals 8 to the power of x plus 3. How do we solve this equation? Well, 4 and 8 are not powers of each other. They both are powers of 2. So for example, it's 2 squared, and 8, it's 2 cubed, right? Maybe we should bring them to the same power. So I'm going to write instead of 4, 2 squared, and raise it to the power of 2x minus 1. And for 8, 2 cubed, and x plus 3. I remember that when I raise power to the power, I multiplied powers. So it's 2 multiplied by 2x minus 1. And on this side, multiply powers is going to give me 3x plus 3. Now, I'm not going to open parentheses and powers. That's just too much work for me. I'm going to say that because the base is same, then the powers must be same. And I'm going to just write down the powers. 2x minus 1 equals 3x plus 3. Well, let's open parentheses and just solve it. You see that it's just linear equation about x. So we have 4x minus 2. I'm opening this parenthesis, 3x plus 9. I'm going to move 3x over here, and I'm going to move 2 over here. So 4x minus 3x is just x, right? And 9 plus 2 equals 11. So my final answer is x equals 11. Okay. Now, guys, sometimes, unfortunately, the powers are not going to be bases of each other. Something like this can happen. Example number 3. We can have 5 to the power of 3x equals 8, for example. And you really don't know, like, okay, neither 8 or 5 are powers of each other. So what should we do in this case? Sorry, in the corner, I think of my previous lecture appears I did not, I think I just opened this notebook without looking like what is in the middle, but that's okay. We're going to just make it a little bit bigger and it's going to disappear eventually. So what should we do in this case? Well, guys, we remember that power exponential function has inverse, and inverse function of exponential function is logarithmic. So, for example, if I have a to the power of x equals b, I can take log with base a of a to the power of x of both sides, log with base a of b. And I know by cancellation equation that this part is going to cancel and x is going to be just equal log with base a of b. Well, usually we do this with equations like that. We have x squared equals, for example, 4. We extract the square root. Actually, we apply inverse on both sides, right? Why don't we apply inverse here? And because base is 5, I'm going to apply logarithm of base 5. So I'm going to apply logarithm with base 5 of 5 to the power of 3x equals logarithm with base 5 of 8. And now I know that logarithm with base 5 and power is going to cancel, and 3x is going to be equal logarithm with base 5 of 8. Or x equals 1 over 3 logarithm with base 5 of 8. And this can be calculated on a calculator. I'm just going to leave it as it is, but normally you can calculate decimal value for this. So very good. You say that even if your base is not same on both sides and you cannot bring it to the same base, you can always take a log. Another example is going to be when you have two different bases and two different powers. Example number 4. Imagine that you have 3 to the power of 2x equals, I don't know, let's use something like 7 to the power of x minus 1. And you see there are two exponential functions here, and the base of this is 3 and the base of this is 7. Which one should we use to take a log? Well, you can actually use either one. It's going to work, but I have a better suggestion. Why don't we take ln? Ln is a natural logarithm of both sides. So ln of 3 to the power of 2x equals ln of 7 to the power of x minus 1. Now, guys, what I'm going to do, remember that the power can be taken outside of ln using the properties of ln, right? So sorry, I'm going to write down 2x by ln of 3. On this side, x minus 1 by ln of 7. Same, I'm taking the power in front. Now, what I have, actually ln of 3 and ln of 7 are not kind of variables anymore. They're just numbers. If you put in your calculator ln of 3, it's going to give you a little bit more than 1. ln of 7 is going to probably give you 1.5. So they're just numbers. What I'm going to do next, guys, my goal is to solve this equation. And to solve this equation, I'll need to isolate x. So here, I'm just going to have 2x ln of 3 copied. And on this side, I'll need to open parentheses, x ln of 7 minus ln of 7. Now I'm going to combine x's together. So I'm going to move this x ln of 7 to the left side, and I'm going to take x outside of parentheses. So x from here is going to leave 2 ln of 3, and this 7 ln of 7 is going to come with minus because it crosses the equal sign, minus ln of 7. And the last step is going to divide by this number. It looks crazy in parentheses, but it's actually just a number. If you enter everything in your calculator, it's going to give you a decimal number. So x equals minus ln of 7 divided over 2 ln of 3 minus ln of 7. So that's actual solution. Looks crazy, but again, you enter everything, plug into calculator, it's going to give you a decimal number. The last type of exponential equation are exponential equations which you can reduce to quadratic equations. Example number 5 can be reduced to quadratic. I'm going to just consider one example. Imagine that you have e to the power of 2x minus e to the power of x minus 6 equals 0. Here, you think, okay, 2x and just x, we can do substitution. T equals e to the power of x. Then e to the power of 2x can be represented as e to the power of x squared, or for us, it's going to be t squared. And instead of equation with exponent, we are going to have t squared minus t minus 6 equals 0. Here, you even don't need to use a formula. You can factor it, I think. So I think I'm going to factor it as t minus 3 and t plus 2. The product is equal to minus 6, and the sum equals minus 3 plus 2 equals to minus 1. So my roots here, t1 equals 3 and t2 equals minus 2. Now I'm going to plug back my original function. So e to the power of x equals 3. So what is x? Well, take a ln of both sides. ln is going to give me a ln of 3. I took a ln of both sides. Here, guys, e to the power of x equals negative 2 looks a little bit strange, because we remember that exponential function was looking like this, right? E to the power of x, and it never has a negative value. So this equation has no solution, because this minus 2 is out of range of the function e to the power of x, out of range. So we have just one solution, x equals ln of 3. I'm going to box it. Okay. Now let's talk about logarithmic equations. So let me move to the green color. And number 2, logarithmic equations. Well, what are logarithmic equations? Well, you can probably guess that logarithmic equations are involving logarithms, right? For example, you can have logarithm with base 2 of x equals 3. How do we understand this? Well, we know that we raise 2 to the power of 3, and we are going to get x. Well, so what is x? Well, then x equals to 8, right? To the power of 3 equals to x. That's a typical logarithmic equation. Well, x can appear as argument. Also, sometimes x appears as the base. We're not going to do like lots of bases. Mostly we are going to use arguments. But, you know, I'm going to consider a couple of examples. Example number 1. Let's deal with logarithmic equation. Logarithm with base 3, x squared plus 1 equals 2. What should we do? Remember that in the previous part of this section, when we were dealing with exponential equations, we were applying inverse function to the whole equation, right? Why we can do this? Because both logarithmic and exponential function are 1-to-1. So if we have same y's, we are going to get same x, and they do have inverses. So here, inverse of log with base 3 is just 3 to the power of, right? So log with base 3 of x, inverse is 3 to the power of x, right? So I'm going to raise 3 to the power of this part and 3 to the power of this part. I know by cancellation equation that this part is going to cancel, and I'm going to have only x squared plus 1. This part is not going to cancel, but 3 to the power of 2 is what? 3 by 3 is 9. And I have x squared equals 9 minus 1, which is 8, right? And x equals plus minus square root of 8. Okay? And that's going to be the final solution. Let's try to solve one more example. Example 2. Let's solve equation. A logarithm with base 3 of 4x minus 7 equals, I don't know, 2. Same. So again, I'm going to raise 3 to both sides, 3 to this side and 3 to this side, and I'm going to cancel and have 4x minus 7 equals 3 squared is 9 again. Well, somehow I have like the same base. So 4x equals 9 plus 7, or x equals 9 plus 7 is what? It's 16, right? And we divide by coefficient of x over 4. So the x equals 4. Guys, when we solve a logarithmic equation, we'll need to kind of make sure that your solution is not going to give you argument of logarithm negative, because we remember that logarithm graph of logarithm is looking like this. If you calculate the argument, for example, you plug in 4 here and somehow you get a negative number, it's not going to work because logarithm with any base is always having logarithm with any base of x. X is only positive. Okay. Well, let's solve more examples on logarithmic equations. And basically, there is not much theory on this. It's just like practice. I'm going to solve a logarithmic equation with x as a base. A little bit weird, but here our standard method is not going to work if we take, or maybe we can try to do it. Actually, why not? So this is logarithm with base x. We can take x and raise it to this power and x to this power. So here x and log is going to cancel and we get 64. And here we are going to have x squared. Now guys, we are searching for x. So we are going to extract the square root from both sides, right? The square root here and square root here. So x is going to be equal to plus minus 8. Now guys, the base of natural logarithms is always positive. So this a is always greater than 0 and a is not equal to 1. So we're not going to use minus x because minus 8 is going to give us base negative. So only one solution is 8 and x equals minus 8 is not going to work because we are defining logarithm with positive base only. Okay, so that's example number 3. And I think I'm going to consider one more example. Example number 4, and that's going to be it. Logarithm with base 3 of x plus 15 minus logarithm with base 3 of x minus 1 equals 2. Guys, why don't you try to solve this example on your own, like for 5 minutes, make a stop on the video, and then watch how I solve it, okay? And I'm going to, as usual, count to 5 and give you the answer, okay? Okay, 1, 2, 3, 4, 5. Okay, guys, what is going to be my way of solving it? I see that I have a difference of 2 kind of logarithms with same base. I remember that I can always combine them back together as one logarithm with base 3, but my arguments are going to become numerator and denominator of a fraction. Why denominator? Because there is a minus here. And now I'm just going to use a standard method. I'm going to raise 3 to this power and 3 to this power. So here we cancel it and we have x plus 15 over x minus 1. And here, what are we going to have? 3 squared is going to be 9. Now we just need to solve it. I'm going to multiply by x minus 1, my equation. And I'm going to get x plus 15 equals 9, x minus 1. So x plus 15 equals 9x minus 9. Well, I think I can move this x over here and this minus 9 over here. So 15 plus 9 is going to give me what? 24. And here 9x minus x, when x crosses through equal sign, it's going to change the sign, it's going to give me 8x. Or x is going to be equal, if we divide by x here and here, x is going to be equal to 3. That's my final answer. Just make sure that 3 is not turning argument into negative. 3 plus 15 is positive and 3 minus 1 is also positive. So everything is fine. That's all about logarithmic equations, and do your homework and practice with doing your homework. Okay.